Hey everybody, this is WireDogSec back with another video for you guys. Today's video, we are continuing on with the Cybersecurity 101 learning path inside of TryHackMe. This is the networking module. This is networking core protocols. Learn about the core TCP IP protocols. Now, hopefully you're all having an awesome day today and ready to learn. So let's go ahead and jump into it. Task 1 is the introduction. It says this room is the third room in a series of 4 rooms about computer networking. Remember, we got networking concepts, essentials, core protocols, which is this room, and then secure protocols. Room prerequisites. To benefit from this room, we recommend that you know the following: ISO, OSI model layers, TCP/IP model and layers, Ethernet, IP, and TCP protocols. In other words, starting this room right after networking concepts is the recommended approach. And learning objectives. By the time you finish this room, you will have learned about the following protocols: Whois, DNS, HTTP, and FTP, SMTP, POP3, and IMAP. Start at the attack box and the start machine, which I have both running now. And let's go ahead and continue on here to task number 2. And first, I need to hit the submit or complete button. Task 2, DNS remembering addresses. Do you remember the IP addresses of your favorite websites? Unless it's a private IP address of a local device, no one needs to worry about memorizing IP addresses. This is in part due to the domain name system, which is DNS, which is responsible for properly mapping a domain name to an IP address. DNS operates at the application layer, i.e. layer 7 of the ISO OSI model. DNS traffic uses UDP port 53 by default and TCP port 53 as a default fallback. There are many types of DNS records. However, in this task, we will focus on the following 4. A record. The A address record maps a hostname to one or more IPv4 addresses. For example, you can set example.com to resolve to 172.17.2.172. The AAAA record. The AAAA record is similar to the A record, but it is for IPv6. Remember that it is the quad A, okay, I guess that's how you say it, quad A, as AA and AAA would refer to a battery size. Furthermore, AAA refers to authentication, authorization, and accounting. Neither falls under DNS. So quad A. CNAME record. The CNAME canonical name record maps a domain name to another domain name. For example, www.example.com can be mapped to example.com or even example.org. The LMX record, the LMX, which is mail exchange record, specifies the mail server responsible for handling emails for a domain. In other words, when you type example.com in your browser tries to resolve this domain name by querying the DNS server for the A record. However, when you try to send an email to test@example.com, the email server would query the DNS server to find the LMX record. If you want to look up the IP address of a domain from the command line, you can use a tool such as NSLookup. Consider the example in the terminal below where we look up example.com. Okay, you're going to be using NSLookup probably throughout your entire career, most likely, at least one time, right? So let's try it. And NSLookup www.example.com. Oh, if I could spell correctly. So let's try this again. All right. Let's see. The query above led to 4 packets. In the terminal below, we can see that the first and third packets send DNS queries for the A and quad A records, respectively. The second and fourth packets show the DNS query responses. And you can see it here with T-Shark. Okay. Which DNS record type refers to IPv6? The DNS record type refers to the email server. So we'll try to find these out and then come back to the video and we will continue. Okay, this first one says which one refers to IPv6. So if we scroll back up here, we can see that the quad A is what we're looking for here. So let's go ahead and put that in there. And the next one is going to be the LMX, which is the mail exchange. Okay, task number 3, Whois? In the previous task, we covered how a domain name is resolved into an IP address. However, for this to happen, someone needs to have the authority to set the A, quad A, and LMX records among other DNS records for the domain. Whoever registers a domain name is granted this power. Therefore, if you register example.com, you can set any valid DNS records to or for example.com. You can register any domain name for 1 or more years. You need to pay the annual fee, and you are required to provide accurate contact information as the registrant. This information is part of the data available via Whois records and is available publicly. Although written in uppercase, Whois is not an acronym. It is pronounced Whois. However, don't worry if you want to register a domain without revealing your contact information publicly. You can use one of the privacy services that hide all your information for the Whois records. Who can look up Whois records, or you can look up Whois records of any registered domain name using one of the online services or via command line tool Whois available on Linux systems, among others. As expected, a Whois record provides information about the entity that registered a domain name, including name, phone number, email address, or email and address. In the screenshot below, you can see when the record was first created and when it was last updated. Moreover, you can find the registrant's name, address, phone, and email here. So you see all kinds of information here. A lot of times this will be filtered out using one of those privacy services nowadays. All right, but back in the day, you could find all kinds of juicy information in there. All right, so if we do let's do Whois example.com, and you can see information about it here. All right, there you go. In the terminal output below, we have used Whois command to look up a domain whose Whois record is protected by privacy protection. Okay, that's what it looks like here. Question time. When was the x.com record created? Provide the answer in the year, month, date format. When was the twitter.com record created? Provide the answer in year, date, or year, month, date format. So try to figure these out, then come back to the video and we will continue. All right, so let's take a look at these here. And we need to do a Whois x.com. And let's see what they say here. When was it created? So we need to scroll. Okay, here we go. Creation date 1993 0402. Looks like it's going to be our answer here. All right, and then we do the same for Twitter. So let's clear this out. Same thing here. Whois twitter.com, and scroll back towards the top area. And creation date 2000. All right, so we got both of these answered. Task number 4, HTTPS accessing the web. And let's see what it says here. When you fire up your browser, you mainly use HTTP and HTTPS protocols. HTTP stands for Hypertext Transfer Protocol. The S in the HTTPS stands for Secure. This protocol relies on TCP and defines how your web browser communicates with the web servers. Some of the commands or methods that your web browser commonly issues to the web server are get, retrieves data from a server such as an HTML file or an image. Post allows you to submit new data to the server, such as submitting a form or uploading a file. Put is used to create a new resource on the server and to update and overwrite existing information. Delete, as the name suggests, is used to delete a specified file or resource on the server. HTTP and HTTPS are commonly used TCP ports 80 and 443 respectively, and less commonly other ports such as 8080 and 8443. In the following example, we use our Firefox browser to access the web server on 10.10.173.123. Our browser fetches the web page and displays it perfectly. However, we are interested in what happens behind the scenes. All right, so I'm going to fire up Firefox here and then navigate to this website and follow along here. All right, it's supposed to look like this image here, the art of espresso, etc., etc. All right, so let's go ahead and plug it in here. It was 10.10.73.123. Okay, there we go. Using Wireshark, we can examine the exchange between the Firefox browser and the web server more closely. The screenshot below from Wireshark shows the text sent by our browser in red and the web server response in blue. As you can tell, a lot of information exchanged between the client and the server that does not get rendered to the user. Examples include the web server version and when the page was last modified. So you can see that here. All right, so you got the red up here and you got the blue down there. Okay, client and servers. Yeah, it says it down there. All right. As you remember from the networking concepts, we use the Telnet client to connect to the web server running on 10.10.173.123 at port 80. We had to send a couple of lines to get an HTTP, etc., and host anything to get the page we wanted. On some servers, you might get the file without sending host anything. You can use this method to access any page and not just the default page. Which is / or root. To get file.html, you would send get and then file.html, etc. For instance, get and then / file.html might work depending on the web server in use. This approach is efficient for troubleshooting as you would be talking HTTP with the server. Question time. Use Telnet to access the file, which is flagged HTML on 10.10.173.123. What is the hidden flag? So try to do that yourself, then come back to the video and we will continue on. Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. All right, so let's take a look here. Now, first off, for practical use, I would probably just use curl command, okay, as I've done here. All right, curl 10.10.173.123 / flag.html. And if we scroll down a little bit, we can see the flag is right here. All right, so I'm going to copy this for later. Now, I did it both ways as well. I did it with Telnet, as you can see here. Telnet, IP address, port 80, then use the get, and then flag HTML. Tried that the first time, it didn't work. Tried it the second time down here. Had to add this host in there, and then it seemed to work because I can see the flag down there. All right, so there you go. Next one is going to be task 5, FTP, transferring files. Unlike HTTP, which is designed to retrieve web pages, File Transfer Protocol, FTP, is designed to transfer files. As a result, FTP is very efficient for file transfer, and when all conditions are equal, it can achieve higher speeds than HTTP. For example, example commands defined by the FTP protocol are user is used to input the username, pass is used for the password, retrieve or retrieve is used to download a file from the FTP server to the client. Store, STOR, says store is used to upload a file for the client to the FTP server. FTP server listens on TCP port 21 by default. Data transfer is conducted via another connection from the client to the server. In the terminal window below, we executed the command FTP and then the IP address to connect to the remote FTP server using the local FTP client. And then we went through the following steps. We used the username anonymous to log in. We didn't need to provide any password because anonymous log on. Issuing LS returned the list of files available for download. Type ASCII, switch to ASCII mode as this is a text file. Get coffee.txt allowed us to retrieve the file we want. The command exchange via FTP client is shown in the terminal below. So let's go ahead and just follow along here. All right, so let's clear all this stuff out. Paste and type in anonymous. All right, no password there. LS, and there's the files right there. Okay. And we need to switch to ASCII mode next, I believe. So type is going to be ASCII. All right, then get. And I wonder if we can just get all these. So let's try that. All right, okay, I guess that doesn't work. All right, so let's do it the long way. Okay, we're just going to grab all these flags. I'm pretty sure we're going to have to get that eventually. And then the last one was T. So T.txt. Okay, so that's done. And we type in quit and call this out. An ls. There's our stuff there. So if we cat coffee txt, there we go. So you get information about looks like yeah, how to prepare Arabic coffee. So there's that. And do the same for tea.txt. Prior instructions about making tea. Let's see. How to prepare Arabic tea. Okay, so there we go. Then of course, last one's going to be the flag.txt. But let's continue on first before we finish this. It says we used Wireshark to examine the exchange messages more closely. The client's messages are in red, while the server's responses are in blue. Notice how various commands differ between the client and server. For example, when you type ls on the client sends list to the server. One last thing to note here is that the directory listing and the file we download are sent over a separate connection each. So we can see that here. User anonymous pass. You can see the rest here. List. Type a retrieve. So we're grabbing that file and then quit. All right. So that's what it looks like inside of a packet here, viewing it inside of Wireshark. All right. Question time. Using the FTP client FTP on the attack box, access the FTP server at the IP address and retrieve the flag.txt. What is the flag found? So try this yourself, then come back to the video. As you can see, we already grabbed it. Okay, so let's go ahead and cat this and get the flag. There's the flag there. So we're done with this. And task number 6, SMTP, sending email. And let's see what it says here. As with browsing the web and downloading files, sending email needs its own protocol. Simple Mail Transfer Protocol (SMTP) defines how a mail client talks with a mail server and how a mail server talks with another. The analogy for the SMTP protocol is when you go to the local post office to send a package, you greet the employee, tell them where you want to send your package, and provide the sender's information before handing them the package. Depending on the country you are in, you might be asked to show your identity card. This process is not very different from an SMTP session. Let's present some of the commands used by your mail client when it transfers an email to an SMTP server. You got hello or hello. Mail from specifies the sender's email address. Recipient to specifies the recipient's email address. Data indicates that the client will begin sending. The content of the email message dot is sent on a line by itself to indicate the end of the what. Okay. The terminal below shows an example of an email sent via Telnet. The SMTP server listens on TCP port 25 by default. And there's an example here. So let's see if we can follow along. All right. So I'm going to copy and paste. Okay. And let's see here. They did hello client.thm. Copy and paste. Okay. Then mail from is going to be this here. All right. Then the recipient to is going to be this here. Okay. And then the data. All right. I guess it's just data by itself. Oh, if I could spell data. There we go. And this is what we need to put in here. So I'm going to put in one at a time. All right. Okay. I think it's looking good so far. And let's go ahead and put this in here. Okay. Did this work or what? Let's see. Oh, okay, there we go. Then quit. All right, cool. So that's done. Obviously, sending an email using Telnet is quite cumbersome. However, it helps you better understand the commands that your email client issues under the hood. The Wireshark capture shows the exchange in colors. The client's messages are in red while the server responses are in blue. So let's take a look. All right, so you got the hello mail from recipient to data. And you have all the information here that's in a typical email address from this email address, then to, and the subject line, then the body of the email would be that here, and then quit out of it. It says, now that we have covered some basic HTTP, FTP, and SMTP commands, you should have gained a solid understanding of how protocols are designed and used. It should be effortless to learn how other text-based protocols such as POP3 and IMAP work. Which SMTP command indicates that the client will start the contents of the email message? What does the email client and the or send to indicate that the email message has been fully entered? So try to find out these yourself, then come back to the video and we will continue. All right, so let's take a look here. The first one, which SMTP command indicates that the client will start the contents of the email message, which means that's going to be the body, so it's going to be data. So if we go back up here, this indicates that the client will begin sending the content of the email message, and the next one's going to be the dot, which is sent on a line by itself to indicate the end. All right, and that should be it. Task number 7, POP3, receiving email. You've received an email and want to download it to your local mail client. The Post Office Protocol version 3 POP3 is designed to allow the client to communicate with a mail server and retrieve email messages. Without going into in-depth technical details, an email client sends its messages by relying on SMTP and retrieves them using POP3. SMTP is similar to handing your envelope or package to the post office, and POP3 is similar to checking your local mailbox for new letters or packages. Some POP3 commands are the following. You got the user, identifies user, password, stat, request the number of messages and total size, list all messages and their sizes, retrieve, or retter, retrieves the specified message. So yeah, retter, and then the message number, and then deli is the message. Deli and the message number marks a message for deletion, then quit ends the POP3 session for applying changes such as deletions. In the terminal window below, we can see a POP3 session over Telnet. Since the POP3 server listens on TCP port 110 by default, the command to connect to Telnet is the following here: Telnet IP address, and then the port number is going to be 110. The exchange between or below retrieves the email message sent in the previous task. So let's go ahead and follow along here, and let's go ahead and clear all this out. All right, and it says auth. Okay, and then we need to do the user, which is Strategos. Okay, and the pass is, I don't know, I guess nothing. All right, well, we don't have that information unless I missed it somewhere. But anyway, this is what the process looks like here. Auth, log in as this user here, then enter the password, then stat, and then list 3 messages here. And those look like the message IDs. Retrieve 3, so retrieving this here, number 3. And I guess this is the information that's in that particular message, as you can see there. Someone capturing the network packets would be able to intercept the exchange traffic. As per previous Wireshark captures, the commands in red are sent by the client and the lines of blue are the servers. It is also clear that someone capturing the traffic can read the passwords. Oh, okay, awesome. Of course, and it's blurred out. So, but anyway, that's what we just saw there. Okay, connect to a POP3 server requires authentication using the following login credentials, or use the following login credentials when needed. Okay, Linda, then this password here. And so let's go ahead and do that. All right, there we go. So let's go ahead and try this again. All right, answering question time. Looking at the traffic exchange, what is the name of the POP3 server running on the remote server? Use Telnet to connect to the IP address of the POP server. What flag is in the 4th message? So try to figure these out yourself, then come back to the video and we will continue on. Okay, so let's go ahead and try this out. First off, we already have it here, it looks like, and dovecot. Okay, never heard of that before, but that's going to be our answer there. And we need to get this flag from this message here. So let's go ahead and follow along, and we need to do auth, right? Yeah, auth. Auth, and then we need the user name, which was Linda, I believe. Yeah, Linda. And then the next one was pass. Yeah, pass. And okay, you gotta do this again. All right. Well, let's go ahead and retype this in. Linda, password. All right, awesome. So what was next after this was to list the messages, I believe. Stat. Okay, and then list. There's the messages right there, and then we need to retrieve with Redder, and then the message ID. This is the fourth message, so it's gonna be for number 4 here. All right, there we go. So it looks good to go there, and there's the flag. Hello, here's your flag. Awesome. So this is done. Now we're going to continue to the next one here. And remember, we got to type in quit to get out of this. Clear this out. Now we're ready to go. Task number 8, IMAP, synchronizing email. POP3 is enough when working from one device, e.g. your favorite email client on your desktop computer. However, what if you want to check your email from your office desktop computer and from your laptop or smartphone? In this scenario, you need a protocol that allows synchronization of messages instead of deleting a message after retrieving it. One solution to maintaining a synchronized mailbox across multiple devices is Internet Message Access Protocol, which is IMAP. IMAP allows synchronizing read uh, or read, moved, and deleted messages. IMAP is quite convenient when you check your email via multiple clients, unlike POP3, which tends to minimize server storage as email is downloaded and deleted from the remote server. IMAP tends to use more storage as email is kept on the server and synchronized across the email clients. The IMAP protocol commands are more complicated than the POP3 protocol commands. We list a few examples below. So you got login and then username and password in the same line. Authenticates the user. Select mailbox. Selects the mailbox folder to work with. Fetch mailbox number, data, item name. Example: fetch 3 body in open and close square brackets. To fetch message number 3 header and body. Move then sequence set. Mailbox moves the specified message to another mailbox. Then copy sequence set data item name. Copies specified messages to another mailbox. Then log out, logs you out. Knowing that the IMAP server listens on TCP port 143 by default, we will use Telnet to connect to the IP addresses port 143 and fetch the message we sent earlier in an earlier task. So let's go ahead and copy and paste this out of here. Okay. Connecting. Okay. Login referrals, enable, etc. A login. All right. So we're gonna need. I'm assuming we're gonna get credentials later on. So this is what it's gonna look like. Login is unable to connect to the host. Ah, duh. If I can put in the right IP address, that would be helpful. So let's try this again. Telnet, then 10.173.123, and then the port's going to be 143. There we go. Okay, so that's what it looked like. Log in, and then logged in. Select inbox, flags permitted for exist, etc., etc. So this is what it's going to look like here as you go through. Okay. The screenshot below shows the exchanged messages between the client and the server as seen from Wireshark. The client only needed to send 4 commands shown in red, and the long server responses are shown in blue. So this is what it looks like in Wireshark. Okay. What IMAP command retrieves the 4th email message? So try to figure that out and then come back to the video and we will continue on. All right, so let's go ahead and take a look at this here. To retrieve the message, all right, if we go back to the commands up here, so it would be fetch, I guess fetch 4 and then body would be our answer, I assume. So let's find out here. We don't need that body in there. Let's try this here. Okay, well, there you go. Awesome. So there's that, and then task number 9 is going to be the conclusion. In the previous room, we discussed the Telnet protocol. This room focused on other fundamental protocols: DNS, HTTP, FTP, SMTP, POP3, and IMAP. With the protocols covered, we now have a better understanding of how domain names are resolved, how web pages are served, and how email is sent and received. Another primary purpose of this room is to give you a good understanding of how a protocol functions behind the graphical interfaces. The table below summarizes the default port numbers of the protocols we have discussed so far. So you got protocol, transport protocol, and the default port number. Telnet, TCP 23, DNS, UDP or TCP 53, HTTP, TCP 80, etc., etc. So there you go. Memorize this information here. Let's join the network secure protocols room and learn how to secure these protocols. Awesome. So we are finished with this room. Hopefully you all enjoyed the video. And if you did, hit that like button. If you're new here, hit the subscribe button. Share the video, comment below any thoughts and opinions on the information discussed in the video. As always, thank you all for taking time to watch my video, and I will see you later.